Evening to Dr. Bahia. I'm Diong Xiao Jing. Today, I would like to present about project linear function and Hooke's law. What is linear function? A linear function is in the form fx equals to ms plus b, where the m and b are real numbers. A graph must be linear, which is a straight line. Means that the curve more than a straight line is cannot. A graph must be a function in order to be a linear function, which is matching each x value to only one y value, such as a vertical line cannot be a linear function. A linear function can also be the form y equals to ms plus b. Y represents dependent variable, m represents slope or gradient, x represents independent variable, and b represents y-intercept. These are some examples of linear function. The first one, positive slope, negative slope, and horizontal slope. And these are some wrong examples of linear function. The first one, vertical line. Why vertical line cannot be a linear function? It is because each x has the same y value and more than one line. Why more than one line cannot be a linear function? Because in linear function, we can see must be a straight line. So in more than one line, besides, it is not a straight line. We can see that the graph is a curve. So it is not a linear function. Now I would like to explain the procedure that I done in the stimulation of the experiment. Firstly, put a ruler below the spring to measure the extension of spring. You can see that the 0 mark of the ruler is put below the spring. Then put a 50-gram slotted mass on the hook of the spring. Measured and recorded the extension of the spring in a table. How to measure? You can see that this is the extension of spring because the ruler, initially the ruler is put below the spring. So this is the extension of spring. Then remove the 50-gram slotted mass. Next, repeated steps 1 to 4 by replacing 50-gram slotted mass with 100-gram, 150-gram, 200-gram, and 250-gram. So, I obtained the results from the simulation is in this table. We can see that when the force increases, the extension of spring also increases. From this graph that I obtained from the simulation, the result of simulation, I can obtain that gradient equals to y2 minus y1 over s2 minus s1. So 34 minus 18 over 1000 minus 500 equals to 0.032 cm per Newton. Also, calculate the y-intercept. By this formula, y equals to mx plus z. Substitute a point into y equals to mx plus c. The point that I chose is 1032. 32, which is the y value, substitute in the equation. 32 equals to 0.032 times 1000 plus c equals to 32 plus c. So we can calculate the answer. C equals to 32 minus 32 equals to 0. Okay, so this is the relationship of line graph. So the graph is directly proportional. The extension of spring is directly proportional to the force applied. The extension of the spring increases when the force applied on it increases. So we can see that this is a straight line. So this graph is considered as linear function. According to Hooke's law, what is Hooke's law? Hooke's law is a physics law states that extension of a spring is directly proportional with force applied on spring as long as its elastic limit is not exceeded. We can calculate the Hooke's law by this formula. F equals to Kx, while F represents force applied on spring, K represents spring constant, and X represents extension of spring. In this graph, the gradient of the graph can be calculated, and the value of the gradient is spring constant, which is K. Based on SI unit of Hooke's law, which is Newton per meter, we can calculate the final linear equation, which is F equals to Kx. So previously, the gradient from the previous graph, which is we obtained 0.032 cm per Newton. So to obtain the meter, we must use this calculation, which is m equals to x over f. So we can calculate the answer, which is 3.2 times 10 power of negative 4 meter per Newton. Converse the formula, spring constant F equals to Kx, K equals to F per X. And the K can be calculated by 1 over this M. We can obtain Newton per meter as a unit of Newton per meter. 1 over 3.2 times 10 power of negative 4. So the spring constant is 3,125 Newton per meter. Okay. What is elastic potential energy? Elastic potential energy is an energy stored in an object that is compressed or stretched elastic. Area under the graph represents the work done to extend the spring. So we can calculate the elastic potential energy by calculating the area under the graph. Work done to extend the spring is stored as elastic potential energy. Elastic potential energy of the spring can be calculated by both of these formula. EP equals to 1 over 2 Fx, or EP equals to 1 over 2 Kx squared. So from this graph, we can calculate the elastic potential energy. I calculated by this formula. EP equals to 1 over 2 Fx. Okay, equals to 1 over 2 times 2,500 times 80 equals to 100,000 Newton per cm. What is elastic limit? Elastic limit is a maximum force that can be applied to a spring. When this force is removed, the spring will restore to its original shape and size. If elastic limit is exceeded, spring loses its elasticity and stops obeying Hooke's law. So when the elastic limit exceeded, the graph becomes curved, and the graph is not linear function. Since linear function is only a straight line. So when until this point, it is considered as linear function, but since the existence of this curve, so it's not considered as linear function. Spring constant is force required to produce one unit extension. The larger the gradient of the line, the larger the spring constant, so the harder the spring and more difficult to be extended. You can see that the larger the gradient of the line, the larger the spring constant, so the spring will be harder. The smaller the gradient of the line, the smaller the spring constant, the softer the spring, and it is more easier to be extended. These are some reference. So the first one is the link of the simulation of experiment. If anyone interested, can do the experiment by your own. That's all from me. Thank you.